In our explanation of why the rate constant exponentially increases with temperature, we're going to first start with the collision model. And the collision model tells us the following. Molecules must collide to react. And the number of collisions is proportional to concentration and is proportional to the temperature. And if you can think about this for a second, the more concentrated something is, the more molecules we're going to have in that container and the more probable they are to collide. Also, if we increase the temperature, we're going to increase the velocity of all of these particles, and you're going to have more frequent collisions. Another thing that we can say for a reaction is that for a reaction to occur, the collision energy must be greater than the energy of activation, which we'll abbreviate as EA. And the energy of activation is the minimum energy needed to observe a reaction going from products to reactants. So if we look at a plot of the fraction of molecules and we look at their kinetic energy, we're going to see a plot that looks something like this. Okay? If this is at a low temperature, we can look at the fraction of the molecules that have a particular energy of activation. So let's just say here's our particular energy. That's our energy of activation. So what this means is, in order for a reaction to occur, the collision energy has to be greater than the energy of activation. So we're going to have this fraction down here of molecules that will react. Okay? Now what happens when we increase the temperature? So if we go to a more high temperature model, we will see something that looks like this. Okay? So here's our high temperature case. We've increased the temperature, we've increased the kinetic energy of the particles. Now look at the fraction of molecules that have a higher energy than the energy of activation barrier. So all of these guys over here on this side, including this little blue area down here, have a high enough energy to react. So as we increase the temperature, we are increasing the kinetic energy of molecules reacting, which means a larger percentage of molecules react to form products. Okay, so we have more collisions, we have a higher activation energy, and we're going to get more products forming. All right. In addition to collision theory, we have to look at the orientation and how molecules collide, because not every collision will result in a reaction. And we will talk about orientation in the next video.